Okay, inductive reasoning on this side of the board. Inductive reasoning in a lot of ways is the opposite of deductive. You'll see that the cone image that we have here is going the other way, and this goes from specific to general. So this takes specific cases and tries to see if there's a pattern there, or put together a few different examples and take a pattern and then extend it. So inductive reasoning is all about looking for examples, gathering examples or observations and trying to find patterns and then extend those patterns. Once we feel like we found a pattern, we're not sure if that's true, but we make a guess. We say, I think this is true. And that's called a conjecture or a prediction. Sometimes in science we call it a hypothesis. But as soon as we find a counterexample, then we know that that observation must not have been true, or that pattern must not have been true. So let me give you an example of that. Let's say you're going to a certain class, right? Maybe a math class. And every day you get homework. So if 2 weeks in, right, 10 days of class, you've gotten homework every single day. Your conjecture after gathering, 10 observations or 10 examples of days of class, you're thinking to yourself, man, I get homework every day. So your conjecture is, I'm going to get homework every day in this class, or every day I will have math homework, right? And then one day comes along, it's a Friday, and your teacher just says, hey, you guys have been working really hard, no homework this weekend. And everybody's like, yeah, sweet, no homework, right? Well, your conjecture now is false because you didn't get homework every single night. Your conjecture was, I'm going to get homework every single night in this class, or every single night this teacher assigns homework. But as soon as we find a counterexample, or an example where that doesn't happen, then we say, okay, well, our conjecture is false. So you can go back and say, well, he's going to assign it most of the time, right? And that can become your new conjecture. When you're looking for a pattern, when you're making a conjecture, you can have a very weak conjecture if you don't have a lot of data. So let's say you show up to class, right, the first day, and the teacher says, hey, I'm going to give you homework. And you're like, oh, we're going to have homework every single night. Well, you don't even know yet, right? You haven't really established a pattern. You've only been there one day. So you might not be very accurate. Now, if after 100 days of class you've had homework every single time, well, then it's pretty likely that you're going to have homework again, right? So you can have a weak versus a strong conjecture, and it just depends on how much data that you have, how much data that you've gathered, how many observations that you've seen. So that's what inductive reasoning is all about. Now, putting these together, a scientist often uses inductive reasoning to form a hypothesis, right? A scientist would say something like, okay, I've seen this happen over and over and over. They just gather data, and then they form a hypothesis, which they then could set up an experiment and use deductive reasoning to try to find, okay, this is true all the time, using laws and things like that. The kind of mnemonic or memory device for remembering inductive reasoning is we think about a weatherman, right? A weatherman doesn't know specifically he doesn't know necessarily without a shadow of a doubt what the weather is going to be like. He just has seen a bunch of data. So he can look back at previous years and say, well, when I saw these conditions over the last 100 years, this is what happened. That's why when it's like, hey, there's a 30% chance of rain, what that really means is in 30% of the days like this, it had rained. Or when the conditions were like this, 30% of the time it rained. So they're going off of previous data, previous observations that they had, and trying to extend those patterns. So this is kind of the weatherman idea. So inductive reasoning, specific to general. You start with a couple specific cases, specific examples, and you try to make a conjecture, you try to figure out if there's a pattern, and then you kind of make a guess. That's kind of the difference between the two. We're going to come back in the next video, and we're going to talk about some specific laws of deductive reasoning that we can use when we're doing proofs. So stay tuned for that.